All right, let's get back into the code from last class. Again, we're trying to merge these things together. Oh, and just as a reminder, if you haven't already done so, I know a lot of people already have, but make sure you take the exam and have it complete by 11:59 p.m. tonight, so I can get it graded over the weekend. Um, And also remember that we will not physically have class on the Monday after break or the Wednesday after break, but there will be lectures up for both of those classes. So there'll be a lecture, I just won't be physically here. All right, and then we'll meet again on that Friday following break. All right. So we're working on kind of connecting our front end to our back end here. Last time we created, let's just go over to the code here. We created the idea of a dungeon where we said a dungeon has a name and that it also has a single starting room. And it is through that room that we open up the rest of the dungeon. So if we go into the room class, we see that a room has a way of getting to potentially other rooms through exits. All right. And a room has exits added to it through this add exit function. Now, the question is where does that all come from? If you remember, inside of our singleton, we wrote a function called generate dungeon. And this guy effectively creates our cross-based dungeon. So we made a bunch of rooms. We added the appropriate exits with the directions to those rooms. We created the dungeon, and then we just let that dungeon know that when somebody enters it, they'll start in room R1. And then from that room, they can start getting into some other rooms. All right. So then we looked at, well, how can we confirm that our dungeon only gets created one time? Well, we initially said, well, we could do this inside of, well, it could be a dungeon controller, it could be inside of player. One of our scripts that exists on every single screen. So if we look at our various things in our scenes, we have Chomp that exists in every scene, and he has a player script associated with them. So that would be one script, one opportunity to put code in there. And then we also have this idea of a dungeon controller that has a dungeon controller script attached to it. So every time we create an instance of our scene, we'll also have a dungeon controller script. So either of those scripts launch every single time we load this scene, and we've seen that we load the scene every single time we enter a new room. Today is where we're going to be linking those things together. So we could say, well, we can go into either one of those guys, either the player script or the dungeon controller script, either one of these guys, and we could create our code that goes in and generates the dungeon only the very first time. And if you remember last class, we wrote that quickly as a, let's call it a not a very good approach to this. So one thing we could do is when this script first starts, we could ask a question if my singleton dot the dungeon is currently equal to null, then we could call the function that we wrote inside of my singleton to actually generate the dungeon for the very first time. This would work just fine from an efficiency perspective. The issue is that every single time we go into a room, we're going to be asking this question. And it's a question that only is going to have a yes answer to it one time, the very first time. So the alternative to this would be to put it inside of our singleton, and when we created our public variable for our dungeon, we just went ahead and asked our singleton to generate the dungeon. Now, with this in mind, we no longer have to have our generate dungeon function public, because we will not be accessing this function outside of our singleton class. We only use it inside of our singleton class for the very first time we generate the dungeon. All right, so we'll go ahead and tighten the reins on this guy. Okay. Now, as we prepare to get this linked into our front end, I guess, what I'm going to do is I'm going to start deleting stuff from our singleton, which should generate some errors in places we've already used these things. So I'm going to keep track of our current direction, because we're already using that logic to make sure we're facing the correct way. I'm going to get rid of our collection of rooms here in our singleton, because now our collection of rooms is housed inside of our dungeon, and where a room actually is just a mechanism to get to other rooms. So we can almost think of our collection of rooms as being distributed across all of our room objects by way of exits. So I'll get rid of that, which means we're also not going to keep track of our number of rooms. Now, we could keep track of what current room we're in. This might be handy for us, or we can do this through our dungeon specifically. I'm going to go ahead and leave that here for now. Actually, let me think about that. Technically, knowing the current room we're in a dungeon is something that might be nice to have accessible in the dungeon. So I'm going to take that out of here, and we'll add it into our dungeon as we need it. Remember, I like to kind of let things organically grow. All right, so in our singleton, and I'm also going to go ahead and get rid of add rooms, because all that is happening inside of our generate dungeon now. So we're moving away from our old test code that allowed us to have our player physically move about something, and now we're trying to dictate what the dungeon actually will look like through this cross dungeon. All right, so we're going to see that's our new my singleton. Now probably created some errors in some other places in our program. Okay, so now when a scene first loads, we doing this inside of dungeon controller. We turn exits on and off. Looks like we are. Okay, so remember, a bunch of stuff inside of our dungeon controller right now is used to kind of randomly set up our dungeon rooms. We no longer need to do that. Okay, so we're going to get rid of a whole bunch of this stuff in here. We're going to keep our public game object array called closed doors, understanding that closed doors ultimately is a collection of the physical exits that the user would see, so we can make sure we turn them on or off, depending if the room we're currently in programmatically has exits in those directions. All right, and I'm going to go ahead and I'm going to get rid of this function for now, just to keep things clean. We might write something similar to it again. Inside of start, we're not going to keep track of the current room. We're not going to keep track of add room. This was back from our assignment when we said that, well, every room has to have at least one exit. Now we've dictated that. We're not going to have a random range of how many exits we have, any of these things. So we're basically getting rid of all that code. We're getting rid of this for loop that went through and flipped a coin to determine if there was going to be exits in our other directions. All right, so now our dungeon controller looks pretty boring. Okay, so what should our dungeon controller really do? When it first starts, we want to find out what is the room that we're currently in. Well, who knows about the room we're currently in? I'm going to make the argument that it is our dungeon that knows what room we are currently in. And we're going to see how we might accomplish that in a second and decide whether or not that still makes sense, or, and kind of this is a good thought exercise. around the idea of the proper use of a singleton versus not having the use of a singleton. All right, so for the time being, a dungeon does have a start room. And then I'm going to go ahead and I'm going to say private room, current room. All right. And at least for the time being here, we're only going to have a single player in our dungeon. All right. So, but before we get to the player part of this, let's just get our initial room's exits looking correct. All right. So when we first add something to a room, we are going to, when we put the player into the room, that will get set as the player's current room. So I guess let's go ahead and just say player, the player. So a dungeon will know what player is in the dungeon, the current room that player's in, and then a dungeon also knows what the appropriate start room for the dungeon is when we first put the player into the room. Now, if we go and look at rooms, we notice that a room currently has a name. It has some number of open doors and things like that. We might come back and modify this potentially. I think if you remember last time I mentioned that right now, our exits and the number of exits really solve the same problem as our open doors and how many open doors. So if we want to kind of let our code dictate what should change, I'm going to come in here and I'm going to say, okay, well, I don't really think we're going to need this code. I know we've already written some logic around this code. Since we have a relatively few number of source code files, if I delete this, it will then cause errors somewhere else in our code that will kind of clue me into where I need to go and fix stuff. Now, if we notice here, both of these variables are private variables, which means they were only accessible inside of this room class. So I know that their use would be limited to just this room class. So when I delete them from here, that's from an old assignment, we'll see that this is where open doors and things like that get set. All right. But now these are public functions. So again, just to simplify things here, and also giving you some additional practice. If you kind of think about as you're working through your homework assignments, one of the challenges that I know many of you still face is when you get an error, you don't know how to fix that error. If I go back into Unity here, right now, I won't be able to run this because there's currently errors in my code. And if you look at the bottom left-hand corner here, it tells me about these errors. We need to get used to looking at the errors and reading what they are saying, because this ultimately dictates where the problem is. All right. So here, this first one's talking about the dungeon controller. It's trying to access the singletons thing called the current room. If I double click on that, it'll take me into that code. Oh, I didn't save this guy. That's why that's still an error. Remember, I made some changes in here. Let me just get back to the normal set of errors. Okay, we'll definitely have some here. All right, whatever did I just click on? Room does not contain a definition of how many open doors. If you remember a couple minutes ago, we deleted that. And it has no accessible method named how many open doors. All right, so we deleted some stuff and we see the errors here. So one of the first things you want to do is read what the error says, and then you can double click on it. It'll take you to the part of the code. Sometimes it's exactly where the error is. Sometimes it's at the next level where the error occurs right before this or right after this. This just happened to be where it got caught. All right, so this starts telling us that we have things that are missing. All right, so just to get things kind of simplified here, I'm going to get rid of our set open door and our is open door. These are things that we wrote previously to kind of support our first attempt at just having a random dungeon, but now we're connecting our backend to this. All right, so now a room is simpler. A room has a name. It has some number of exits. Now, a room should also have a player, private player. Now I need to remind myself of something here. If I remember correctly, my player class is actually something that should be called player controller. All right, so let me go and fix that just so we've restabilized stuff to good naming conventions. So back in our project here, if you remember a couple of classes ago, we created two folders in our scripts folder, one for all the things that are mono behaviors. So these would be scripts that we attach to game objects, and then all the things that are normal classes. Now, originally, I had put player inside of here because its name, player.cs, the C# file for our player, wasn't actually a traditional object. It was a mono behavior. We want our player's traditional object to mimic, well, to hold the data about a player, where the thing that controls Chomp here, since Chomp is the visual version of our player, we would probably want this guy to be named player controller from a naming convention perspective. So anything that's a controller, we might say that clues us into the idea that this is something that controls a game object in Unity. Whereas anything that has just a solid name on it is probably something that's holding programmatic data and is not a mono behavior. All right, so now since I changed the name of that file, our player controller, I also need to make sure I update the name of the class because the class must match the name of the file. Okay, so I update the name of the file to player controller, and now I have a class named player controller that does all the stuff a player controller used to do, dealing with coming into the room, heading in the right direction, and all of that stuff. So we'll make sure that that is still connected once we get a little deeper into this. All right, so now we're able to go into Unity, go back to our normal classes, and now we can go ahead and create a player script inside of our normal script thing. So this will just be called player. All right, so here's our player class. And the first thing we'll do is we'll dump the mono behavior because this is going to be something that's going to hold information about our player. All right, we're going to say private string and we'll say a player always has a name. We'll also say private room, current room. A player always has the room they are currently in. So a player becomes aware of the room they're currently in. That's something that's probably going to be important for us. So let's write the constructor now for player. So the constructor will take in a string name. And we'll say this dot name is equal to name. Ay, ay, ay. And then we'll go ahead and say this dot current room is equal to null. So when a player is first born, before he's ever put into a room, we will have his current room being set as null. All right. Now, a player will initially be put into a dungeon, and that dungeon will put him into the starting room for that dungeon. All right. So if we go back to our dungeon class, we can go ahead and create a function here called add player. that takes a player as a parameter. So this is adding a player to our dungeon. Now, what we'll do right off the bat is we're going to say this dot the player is equal to the player. So we'll let our dungeon object know at the top level the player that's currently in the dungeon. Now, keep in mind, this currently presumes that we will only ever allow one player in our dungeon. So at this point, it's not going to support multiplayer-y type stuff. We'll address that later on. So a dungeon can only ever have one player in it at this point. So it'd be a single player game, let's say. So when we add a player to a dungeon, the dungeon will remember who the player is. And then we probably would also go ahead and add that player to the starting room of the dungeon. Okay. So let's look at room. A room currently has a name, a collection of exits, including how many exits, and then it will have a current player. When a room is first born, when it first comes into existence, it will not have a player in it yet. Players will get added to a room later on. All right. So I'll go ahead and inside the constructor for room, we'll initialize the current player to null. There is not a player in this instance of room yet. But then we're going to create an ability, because remember, current player is private. So if we want to ever set this to a value from outside of this class, we need to have a setter. We need to have a function that is accessible outside this class so that we can set a private variable inside this class. So we'll say public void. We'll call this guy add player. It'll take a player as a parameter. And we'll say this dot current player is equal to the player. So the player we just added to this room, our room, this instance of room will remember that that's the current player in this room. All right. We're probably also going to have a remove player that sets it back to null. We can go ahead and, well, let's not put that in yet, because we haven't removed a player from a room yet. We'll let it organically happen. All right, so now a room knows how to have a player added to it. So we'll go back to our dungeon. So when we add a player to the dungeon will remember that remember the player that is currently participating in this dungeon. But then the dungeon will also say, take the start room, and we're going to add a player to that start room. And that start room is the player. Okay. Now, in this case, by saying the player here, it's talking about this version of the player. But I could also say this dot the player and talk about this guy, because these guys on line 25 are synonyms because I made them equal to each other right here. So the global the player is holds the value of our more local the player variable here. So the player and this dot the player currently hold the exact same value. All right, so when we add a player to the dungeon will remember the player that's currently playing this dungeon, and then we'll go ahead and add that player to the starting room of this dungeon. Okay, now this all presumes that we've already set the start room for our dungeon prior to calling add player, so we could put some error checking in here and say something like, if the start room is not equal to, or if the start room equals null, don't let them add the player. So only if it's not equal to null will we let them put a player into the room, because if you can't add a player to a room that doesn't exist. But we'll leave it like this for now, since we know inside of our singleton, when we generated our dungeon, we did set the start room for that that dungeon. Okay. So So adding a player to the dungeon also means we're adding him to the start room. Now, when do we actually put this player into the dungeon? Okay, so now this gets back to the conversation we had last class. And that is, where is the correct place to create our instance of player and then add that player to the dungeon? Go back to our singleton. Our singleton currently does not know about a player. At this point, we've written some code that references a player as if it exists, but we're not actually bringing the programmatic version of our player into existence here. Where would we do that? Well, let's look at some of the possibilities. When our game first launches, we know that the player class is the programmatic side, the back end side of Chomp. All right, so this is the guy that will hold an instance of player. Now, the idea here, though, is if I'm wandering around my dungeon, going into 20 different rooms, I don't get 20 different instances of player. The player exists one time, and we don't keep overwriting it. Instead, we keep updating our instance of player such that it is part of the such that it knows where it's currently at in our dungeon. All right, in case we need to access that that information. Okay. So where can we put that? Let's look at our singleton first, because that's where we put our dungeon. And we're going to see where we have a potential problem. So let's say inside of here, we decide we're going to have a singleton keep track of a player. And we can say new player, like something like that. All right, so we've created an instance of player. Then we create our instance of dungeon. All right, now let's just say that at the very bottom of generate dungeon here, before we return it, we go ahead and say the dungeon dot add player my singleton dot the player. All right, so if we do it this way, now we have a potential problem. And this is something we've run into before. This line of code right here presumes that my singleton dot the player already has a value. We haven't necessarily, we don't know for sure that this guy will get a value before this guy gets a value. We're pretty sure, but this ultimately comes down to how does Unity process singletons like this? All right. So what I would propose is to ensure that our generate dungeon has a player. What we do is we go ahead and say my singleton dot the player is equal to our new player. So this would happen while we're building our dungeon. Now, this assumes that our player is always going to be Mike, and we always put him into the thing as we're generating our dungeon, but that's okay for right now. All right, so part of creating the dungeon is also creating our instance of our player, and then ultimately adding that player to this dungeon before we return the dungeon. Okay. So we know that after generate dungeon here, this guy will get a value. All right, because that value will get set right here as part of generating the dungeon. All right, so now we know about a player. The player's been put into the dungeon. Putting a player into the dungeon also puts a player into the start room of the dungeon. All right, so now when we first come into our game, Now keep in mind, a start room for our dungeon, in this case, inside of our singleton here, we set our start room as room R1, which is this guy right here. And R1 only has a single exit leading to the north. All right, so when the scene first starts, we have to ask the player, what room are you in? That way we can make sure to make this room look like that room. All right, in terms of the exits that it has. All right, so let's go into our player controller. So remember, our player controller is a script that is actually I'm going to go ahead and close this and reopen it from in here. I think because of the way we deleted it, then recreated it. There we go. It wasn't highlighting the stuff. All right, so we know that every single time we have a scene, this script is attached to our chomp guy, our visual version of our player. All right, and that guy will have to make some decisions about what exits should exist and things like that. Because notice that a player here, we decided that this player keeps track. He's the one who's turning exits on and off, although this is for I think this is for him going through exits to certain directions. All right, so we're gonna say that who's in charge of making a dungeon have exits turned on or off. Here's our collection of closed doors. So these are our game objects. So it's actually our dungeon controller that's going to have to find out the room the player's currently in. All right. So how does the dungeon controller find out what room the player's currently in? Well, he has to ask our singleton about the player and then find out from the player what his current room is. And since this is a private variable, a player has to give us access to the current room, and we will return this current room. Oh, I'm sorry, player. All right, so this is a private variable inside of player, so we only have access to this variable inside the player class. So we'll write a public function called getCurrentRoom inside the player class and allow it to go ahead and hand somebody else a pointer to the current room this player's in. They can't change it with that pointer, but they can get access to it. All right. So back inside of Dungeon Controller, we're going to start off by finding out what is the current room this player is in. So room, the current room is equal to my singleton dot the player dot get current room. All right. So when our dungeon controller first launches, which happens every single time we create our scene, we're going to go ahead and grab the current room we're in and ask the player to and get that current room that player's in. This then allows us to set up the appropriate exits because we have all of these closed doors. All right, and if I remember correctly, we can decide whether this made the most sense or not, but it is the way we did it. I think we have north, south, east, west. If I click on my dungeon controller, bucket 0 is north, bucket 1 is south, bucket 2 is east, bucket 3 is west. So those are our 4 things there. Okay, and if you remember, inside of a room, we keep track of exits and we add exits to rooms with directions. So when we create an exit, that exit has a direction as well as a destination room. All right, so what we need to do is we need to be able to go through our room and say, do you have an exit to the north? If yes, I'm going to show the north exit. Do you have an exit to the south, the east, the west, so on and so forth? All right, so I'm going to create a function inside of room that's going to return a Boolean. We're going to call this guy has exit. It's going to take a direction. And this function will allow us to say, does this room have an exit in the direction of direction? All right, whatever direction is. We would pass in north, south, east, west. All right, so we're going to have a for loop here. So for int I is equal to 0, I is less than the exits. Well, actually, the exits dot length will always be 4. But how many exits is the number of exits that we've actually put into this room? So we really need to say this dot how many exits. The most number of exits a room can have is 4, but not all rooms have 4 exits. And remember, we added an exit here, and this puts stuff into our array of exits. So when we want to find out if a room has a certain exit, we're going to go through our list of all of our exits. And then we want to start asking a question. We're going to say if this dot the exits at bucket I, so that is the current exit that we're interested in. Okay, now we need to get the direction of that exit. So if we go into exit, we see that direction is private. We need to go ahead and give ourselves a public string get direction and have this guy return this dot direction. So we gave ourselves public access to this private variable, but it's read-only access. Okay, that's preferable over just making this guy public, because if we make this guy public, then anybody outside will be able to update the direction. We don't want them to be able to change it. We want them to just be able to access it. All right, so we can now ask an exit for its direction. So inside of room, inside of our has exit, we're going to go through all of our exits. We're going to, for this particular exit, we're going to get the direction. And we want to know if that direction is equal to the direction that was passed in to this function. Because we're trying to find out, does this room have an exit leading in this direction? So we're going to go through all of our exits. Each time through, we'll say, does the current exit direction equal the direction we're interested in? If it does, we'll go ahead and return true. We have found an exit that goes in that direction. All right, and has exit should return true in that case. Now, remember, return makes a function immediately end. So even if it's just my very first time through this for loop, if I find the exit I was looking for, I return true, this loop is over, because this function now has ended and returned a value. Now, if I get after this for loop and I'm still alive, that means I have checked every single one of our exits and none of them match the direction I was interested in. Therefore, I'll return false. It does not have an exit in that direction. Okay, so now we have the ability to ask a room, an instance of room specifically, since this is not static. We have the ability to ask a room whether it has an exit in a certain direction. So we'll go back to our dungeon controller. Inside of start, we have our starting room. We have our starting room. And now what we want to do is we want to find out what doors should be existing or not existing to create blockades. All right. So we want to ask a question. We have 4 doors to work with. So we want to say if the current room dot has exit to the north. If that's true, then we want to say this dot closed doors at bucket 0 dot set active to true. We'll go ahead and turn that exit on. Now remember, by default, we have our closed doors here, and notice that our closed doors, let's see, by default, they are, active. So do we want to set them as inactive here? Do we want to programmatically set them as inactive? Let's do it programmatically. So let's write a function inside of Dungeon Controller called private. You know what? Why? Why write extra code when we can just have it be the default behavior? So we'll select these 4 guys. So these are our 4 doors. And by default, we will go ahead and just turn those guys off. All right. So I selected all of them and then just hit this button right here. So even though they are technically available, they are not turned on. All right. Which then allows us to encode, ask these questions. If there should be an exit to the north, turn that door on. We're going to do that 3 more times for the other potential exits. So south is bucket 1. East is bucket 2. West is bucket 3. All right, so when our dungeon controller first starts, he'll grab the current room the player's in, and then he'll make sure he turns on the active exits so that they show up as an exit you can go through. Which means our very first room, the very first time through our dungeon, we have our thing that looks like this. We get put in R1. There should only be an exit to the north. All right, so let's go and see what other problems we currently have. So when a dungeon controller first comes into existence, it does this. When a player controller first comes into existence, this is so this north exit, south exit. Let me just go and look at what those guys are real quick. So for Chomp, he has these various exits. Okay, yeah, those are the colliders and things like that. So that's not the physical doors. So we're good there. All right, so these guys are unrelated. Turn off the exits or whether or not we have colliders over there. We'll deal with the logic of that later on. All right, so I think we're okay in this case. All right, this guy is complaining that we already have a player named Player. Now, this is kind of a common issue. Remember, we went in and we renamed this project. So it's talking about this global namespace already has a definition for something called player. I am pretty sure the fix for this is to make sure your project is saved. I'm going to go ahead and close Unity. And then reopen it, and I think it'll reload the namespace to get our updated file name put back in there. Just getting the spinny wheel of death here. kill off Unity here. Go back to our Unity hub. Reopen this guy. Seems to think my project was already open. I'm just going to quit that. Things got a little, I guess things are still sketch. No, it's things I still have a project open. Doesn't look open to me. Oh, I bet you it's because Visual Studio is holding it open. So I'll kill off Visual Studio as well for right now. I'll save all of my files. Now we'll try to reopen this guy. I guess we're just going to go and say ignore and let it open it. I don't know why it continually thinks it's open. I need to rebuild. Build settings. But why? Let me just open this code up. It's definitely related to us renaming that file. And I might just need to go into my downloads here. Actually, I can do this to get to the file most easily. So I'll reveal in Finder. All right, so here's those files. So I want to say it might be this metadata stuff. So I think these are generated when we create a new file. So let me go into my mono behavior scripts. Okay, we have that guy fixed. Is that guy the one that's not rebuilt? Already contains a definition for player. Do a clean. Okay, let me try doing clean all in here. Let's see if that fixed it, then I'll tell you what that does. Does not seem to make a difference there. What if I make a little change to player and then save it? Let's put a space in there. Doesn't seem to know about this guy. All right, well, so my feeling is I just need to restart Unity, but completely restart Unity because it doesn't seem to like the way I'm shutting it down. So I'll just get that restarted correctly. What we'll see at this point is when we load into the game, as soon as it's convinced that those the file names are not in conflict, we'll be sitting in a room with just an exit to the north because that is the room the player is currently in. All right, by our code. Player's in room 1, which is the start room of our dungeon, and it only has an exit to the north. All right, so questions, comments, concerns, bribes. All right, so make sure you get the final exam done by 11:59 p.m. tonight. I will be creating the next two lectures for this project. I'll get this namespace thing fixed here real quick. I think I probably just need to restart my computer because Unity seems like it has another instance open that it's upset about. And then we'll ultimately get our player able to move around the dungeon, but updating the dungeon behind the scenes. So we will visually see the room we're actually in, yet we're updating things behind the scenes. So we'll make those two things match up. All right. Well, everybody have a safe spring break. And I will see you the Friday after spring break. But there'll be lectures up for the Monday and Wednesday class. All right.
Have a good break, Professor.
Yep. You take care.